How are you? Today I'm in Mostar, in front of the church, which is known as much for its dome as also for its lovely decor. When we're near big structures like this church, it really brings home to us what a lot of thought went into building them. But thought must go into small structures too, like cars, where the parts must be shaped to fit in well together. In today's programme, Corazon and the students will build a simple motor, which is powered by a battery. We're going to meet a group of researchers at the University of Malta who built a robot and equipment which can read mind signals called EEG. Noah will go to Oxford in England to meet Katrina Buzatil, who works in one of the most prestigious scientific material publishing houses. And finally, I'll meet with a group of students at MCAST who are studying robotics.
In our other experiments, we might have used things or ingredients which are not that common in houses. In today's program, we are going to talk about things we use every day, so they're easy to find at home. There is no excuse for not trying this experiment out. But now, let us meet our guests on today's program.
My name is Sean and I come from St. Augustine's College.
I'm Lara from Sir Luigi Preziosi School.
I'm Bernard from St. Augustine's College.
I'm Rachel from Sir Luigi Preziosi School.
I'm Andrew from St. Augustine's College.
I'm Janice from Sir Luigi Preziosi School.
I heard that today's experiment will be something that revolves. That's all I know. I don't know what exactly we'll be doing for today's experiment. Sean, can you tell us?
Every day and everywhere we look, we see things that turn or revolve. For example, clocks, toys and fans. All these things use electricity. Today we're going to build a simple electric motor.
This sounds like a promising experiment, but aren't electric motors very complex things?
They are rather simple to make. All you need are 2 magnets and a battery.
Sean, let's stop there for a moment. Let's turn to Andrew. Can you give us the exact list of what we need for today's experiment?
For this experiment, we will need a size D battery, insulating tape, 2 metal paper clips, sandpaper, a pair of scissors, about 1 meter of thin insulated wire, a stick of glue, thick rubber band, a magnet.
As you can see, these things are really easy to get hold of. What could those who didn't manage to write down all the things we need for this experiment do?
Right now, you can see the address of our website. You can visit the site and get the list from there.
Very interesting. Let us watch the first feature. We'll continue the experiment afterwards.
We're at the University of Malta. I came to meet Owen Falson, who is a student at the Faculty of Engineering. Pleased to meet you.
Hello, thank you.
Owen, where were you brought up in Malta?
I was born at Halua and I was brought up and lived there all my life. And all my family lived there as well.
And what made you choose a scientific career?
I have loved these subjects from a young age. I was always curious about how things worked and I was always disassembling toys and other things. At school, I always preferred subjects like maths and physics, and this is why I chose this career. Let me introduce you to the head of this department, Dr. Simon Fabry.
Dr. Fabry, what kind of research goes on in this department?
In our Control Systems department in the Faculty of Engineering, we are concerned with a group of machines which are computerized or software-based, which try to incorporate an idea of intelligence in their engineering system in order to imitate the way a human thinks or plans things as much as possible.
We're in another part of the laboratory, and we're now going to meet Marvin. Marvin, what does this equipment do?
Well, this is a robot, and we use it to demonstrate just how good its control system is by trying to balance this rod, which isn't stable by itself, okay? Just like you try to balance this rod on your fingers, and it isn't always easy to do so. Can you try it? Now, what this robot is going to do is to try to balance out this rod, but it's going to do it much better than you or me. I'll switch it on, and it will try to take it up and it will try to balance it. That means that if someone tries to unbalance the rod or drop it, it will try to balance it as much as possible for it not to drop.
This is on my M4. Okay?